Video number 109, graphing quadratic equations. And we're going to look at the a value not equal to 1. But first, before we start not equal to 1, let's remind ourselves what the mother graph of the quadratic looks like. First of all, remember what an equation is that has two different variables. Is simply nothing more for a graph. What we want to do is just find the solutions. Well, when x is 0, so is y. So therefore, that's a correct answer on the equation. So that's a correct answer on the graph. When x is 1, y is 1. When x is 2, y is 4. So here's 1, here's 1, here's 2, maybe there's 4. There's 2 and 3. So 1, 1, 2, 4. And of course, negative 1 plus or minus. So negative 1 gives you a positive 1, and negative 2 gives you a positive 4 also. So what we're looking at here, that's where you get the quadratic shape, the parabolic shape. Because you could see here also that if you plugged in 3, you would get 9, right? And if you plugged in negative 3, you'd also get positive 9. So this is the mother graph. So what we're looking at here is this. Let's summarize, okay? We're looking at going 0, 0, then to the right 1, up 1. To the right 2, up 4. Or in other words, to the left or right 1, left or right 2, and up 1 and 4 respectively. So this is what's always going to happen, this shape. Of course, we could do to the left or right 3 and then up 9. Okay, so we could have gone 3, comma 9. All right, now let's go to the next one. The next one has the a value at negative 1. All right, well, what's going to happen here? All this is saying is take the y values, make them negative. See, the equation tells the story. Y values are negative. So 0, 0, to the right 1, down 1, to the left 1, down 1, to the right 2, down 4, to the left 2, down 4. Right there. All right? So that's the a value at negative 1. Next one. Right here. It says now take the y values for a quadratic and add 3. Add 3 to the y values. Right? What does this say? Y is x squared. So what's x squared? Nothing more than a y value. Y values plus 3. So you're instead of at 0, 0, instead of 0, 0, what are we going to use? 0, 3. Okay? Instead of 1, 1, 1, 4, because we're going to go plus 3. Instead of 2, 4, 2, 7. All right? So here we are at 0, 3, 1, 2, 3. There's that. Let's get a new pen here. Here we go. 1, 4. Right there. To the left 1. There it is. To the right 2 and up 7. So 4. That's 5, 6, and 7. Right here. Right here. And there it is. The parabolic quadratic. All right. So what happened here? Y values went up 3. There it is. Next one. What is this telling us to do? It's telling us to take the y values and do what? Multiply them by negative 2. So 0, 0. All right. Instead of 1, 1, we're going to go what? 1, comma, negative 2. All right. Instead of what used to be 2, 4, we're going to use 2, comma, negative 8. So instead of going down or up 4, we're going to go down 8. 2 times 4. So 3, 4, 5, 6, 7, 8. So it makes the graph skinnier, or if you want to refer to it as being taller, right? Right? There it is. So these are just quick graphs here. We're identifying some patterns, going through here and getting the job done. Here's another one. What is this? What's the story being told here? What story is it? The y values, we're going to add 7, and then we're going to multiply by -3. Alright? So where's the vertex? 0, 7. Right here. Now, the -3 is going to bring the y values down by a multiple of 3. So instead of going to the right one, I'm sorry, down 1, or yeah, to the right one and down 1, we're going to go the right 1 and down 3. So here you are at a 7. We're going to work our way down to a 4. So I guess we're going to put all these here. 6, 5, 4, 3, 2, and 1. So 1, 2, 3, 4, 5, 6. No, I messed that one up. Alright, we'll call this a 7 here. There we go. Alright. 1, 2, 3, 4, 5, 6, 7. Okay. To the right 1 and down 3. That's going to put us at 6, 5, 4. Right here. And then same thing on the -1 side right here. Now, so we got 0, 0 became 0, 7. 1, 1 became 1, 4 because we went down 3. Now, instead of 2, 2, guess what? 2, right? And what are we going to go down? We're going to go down what? 12. Does that make sense to you? Because it used to be what? 2, 4. There you go. That's better. So 1, 1. So 2, 4. So now we're going to go down 12. Why? Because 4 times -3 is 12. Okay. So we're going to go to the right 2 from our vertex and down 12. Down 7. And then what? 5 more. 1, 2, 3, 4. 5 more. Alright. To the left 2. Bam. Down 12. Right. To the left 2 and down 12. There's your quadratic shape. Okay. By the way, you could have plugged a 2 in instead. Plug a 2 in for x. Alright. You're going to get y equals, alright, -12 plus 7. What is that? -5. There it is right there. Okay, so it still works out. Now, the next one. Hopefully you understand how to calculate to find a vertex. Hopefully you know that the vertex is where? The vertex is definitely 3, -4. I'm sure this is in one of the videos on this blog. How do you find a vertex again? Well, whatever number zeroes out the squared, the 3 is what makes the x value of the vertex. Plug in 3, that makes this a 0. And when this is 0, y is -4. Bam. Alright, now, so our vertex is 3, -4. To the right 3 and down 4. Okay, we're just going to do it this way. We're not even going to put the lines in. Alright? Now, what number's in front? -1. Right here. Bam. So, we're going to go to the right 1 and down 1 because A is exactly 1. We're basically going to use that pattern on the second quadratic of this video. So it's going to be 1, -1, 2, -4. Of course, plus or minus. Okay? So we're going to go over to a 4. That's going to take us down to a -5. Go over to a 2. Take us down to a -5. Go over to 5, which is what? 2 away from 3. Instead of going up 4, we're going to go what? Down 4. To the right 2 from here, down 4. So that's going to take us to a 5, 6, 7, and -8. Okay? And same thing with 1. Because where is 1? Just like 5, they're both what? 2 away from 3. 2 units away from 3. That's why it's a 4 for the quadratic shape. Alright? Now, to bring this thing home, to really bring this thing home here, we're going to use what's called the vertex formula. Vertex formula, you ready? Here it is. You're going to use -b over 2a, comma, f of negative b over 2a. Alright? Does everybody agree that negative b over 2a is negative 6 over 2 times 3? Alright, which is negative 1. So therefore the vertex is negative 1 comma f of negative 1, hence the f of negative b over 2a. F of negative 1 is, well, that'll be a 1 times 3, 3 plus 6, 9 minus 2, 7. Negative 1 comma 7. 7, negative 1, right here. Now, what we're going to do next is we are going to, is that right? Negative 1 comma 7? Negative b over 2a, negative 6 over 2 times 3. Yeah, negative 1. Bam. Negative 1 plugged in there. Oh! It's not 7. Excuse me. Let's see here. F of negative 1 is 3 times negative 1 squared. Minus 6 minus 2, which is negative 5. Negative 5. Negative 1, comma, negative 5. There we go. Okay, so this is... Alright, now... Okay, we're going to use the fact that the 3 here is the a value. Then we're going to use what we learned in this video, or this problem, over here, where we multiplied the y values by a negative 2. So 1, 1 became 1, negative 2. 2, 4 became 2, negative 8. Alright? Bam! So, we're going to go to the right 1 and up 3. Right there. That's going to take you to a negative 2. So 0, negative 2, which of course you can see that's the y-intercept. Negative 2 is also going to have a height of negative 2. So you're going to the right 1. You're at negative 1. You go to the right 1 up 3, left 1 up 3. Now we're going to go to the right 2. 1, 2. How far up are you going to go? Not 4, but 4 times 3, 12. You're going to go up 12. That'll take you up to the 7. That's probably what I was thinking. Yeah, right. Yeah, I just made a mistake, but yeah. There you go. All right. So there's your quadratic shape. I know it's a little messy here, but hey, it gets the job done. Okay, so just take your time trying to teach the video here, so you should be in good shape. All right. Now, by the way, if you found f of 0, you would get negative 2 if you plugged it in, which would be the same thing as f of negative 2. Okay, they're both one away from the vertical line x equals negative 1, which is referred to as the axis of symmetry. Then if you found f of 1, that would give you 7, which would be the same thing as f of negative 3. Those are both 2 away from negative 1. There's one other way to do this, same problem, without using the vertex formula. What you could do is you can factor out the 3. So we're going to factor out this 3 and call it x squared plus 2x. Okay? We're going to put the minus 2 on the outside. Then we're going to complete the square. Alright, we're going to complete the square on the inside. To complete this perfect square, that would give you 2 over 1. Now watch the other videos, but you're going to end up adding plus 1. Now, what we really do here, we just basically added 1 to the right side of the equation. So we could add 1 to the left, or we could subtract 1. But did we really add 1? We just basically added 3. So you're going to have to subtract 3 to balance that out. So you're going to change this to 3 times x squared plus 2x plus 1 minus 2 minus 3. Alright? This 1 really represents a 3 because the 3 in front. Now, this changes to 3 times x plus 1 quantity squared minus 5. Guess what that is? That's the vertex. Gives you negative 1 comma negative 5, which is what we found just a moment ago. Right here. Now, do the same formula. See the number in front? A is 3. So we're going to go to the right 1 and up 3. Negative 2. Alright. To the left 1 and up 3. Bam. Okay. To the right 2, which takes you to a 1, and up how much? 3 times 4. That'll be up 12, which takes you up to a 7, because you have 5, 7 is a total of 12. Just to emphasize the situation from the last video as well. So then here you go. Right here. And you're all set. Alright, questions or concerns? Give me an email. Good times.